This property that is introduced and has examples in question 17 is very significant property in that it shows the connection between the log and the exponential, in that if I had a number, say this number A, and I took the log to base E of A. So I've done a calculation on A, and that calculation is I've taken the log, or I've calculated the log to base E. If I then take the answer to that and I perform the exponential of that, so I'm going to raise E to this now, that's performing the exponential, then the result is it gets me back to A. So I started with A, I performed one operation called the log, I performed a second operation called the exponential, and I got back to A. So what it's demonstrating is that the exponential undoes what the log function does. Now, when one undoes the other, they're called the inverse. So the exponential is the inverse of log. It undoes it. It's a little bit like squared and square root. So if I square a number and then I take the square root of the result, it gets me back to the original number. We don't do a lot on inverse in this course. However, in Extension 1 you do a significant chapter on inverse, and you look in particular at a lot of trig inverse trig ratios. But for now, please be aware of this connection, and it is required that you understand that the inverse and the log are, the exponential and the log are the inverse of one another. And so you get to use this property algebraically. Like it's saying here, it can be extended to be y is x to the log of the number y to the base x, just meaning that here it was specifically base e and e to the power, whereas we can actually extend that to include any base, log to any base of a number. If we take that base and raise it to that log, then we get back to the number. Just going to step you through a process that actually is almost a proof of this. And it's not that you have to know this proof, it's just that if you can follow the steps logically through, then it's a good indication that you've got very good understanding of logs and exponentials. And I think it's worth going through the steps just to reinforce that you do understand logs and exponentials. Like I said, you're not going to be asked to prove this property, but this is an actual proof. So if we start off with y is equal to e to the log of a to base e. So you can see that we've got the right hand side, e to the log of a to base e, However, we're not saying at this stage that it's equal to A, we're saying it's equal to Y. Now, in a proof, you would know that you were then trying to show that Y is actually A. And that's what we're going to work towards, showing that Y and A are actually the same. And if Y, we can make the statement that Y is actually equal to A, then of course we can write this property. Okay, so let's get started. We've got Y is equal to this statement. Now we're going to take the log to base E of both sides. Now, this is sometimes a technique that you may need to use from time to time in a solution. This idea of taking the log of both sides. This is a good example of where you need to do it within a proof, but you might find you need to do it in a show question. So it's a nice example to work through to see this technique actually coming up. So if I'm taking the log to base E, I can abbreviate that to ln. So of both sides, so it's log Y, and I'm going to take the log to base E. Now, how did I write that? I think I'll just write it as ln. ln of E to the log base E of A. Now, I'm going to work on this right-hand side. If we've got log of anything to a power, there's a rule that says you can take that power and bring it to the front of the log, and that's this rule. If you've got log of A to the power B, you can bring the B to the front times log of A. So we're going to use that to rewrite this right-hand side. So we're leaving the left-hand side the same. However, we're bringing that log to base E of A, log to base E of A, to the front like a coefficient out of the power, and we're just leaving log of E. What do you know that log E is? What base do you raise E to get E? Well, here it's telling us it's 1. So the right-hand side has log E simplified to 1. The left-hand side still stays the same, but this is log to base E of A, which we're going to write in our abbreviated form. Log to base E is ln of A. Now, have a think of what you've got here. Log Y is log A. Two things, either side of an equal sign, both operations the same. What do you know about Y and A? You know that Y and A must be equal. And that was what we were trying to show, that Y was actually equal to A. So now sub Y equal to A back into 1, and you've got the property that we'd set out to actually prove. Like I said, that's just a nice little process of a proof with some quite useful understanding of logs and exponentials. And of course, it's critical that you understand that we've introduced a technique of taking the log of both sides, which is possible once you've got an equation. You can take the log of both sides. That's fine. Okay, could I please get you then to do question 17, and in exercise 3B, do question 3.